From Photonics Media, this is All Things Photonics, a podcast where we explore industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, we'll speak with some of the brightest minds in industry and research about the trends shaping the landscape of photonics.
Today's episode is brought to you by Hamamatsu Corporation, a leading manufacturer of devices for the generation and measurement of infrared, visible, UV light, and X-rays. Hamamatsu is dedicated to the advancement of photonics through extensive research and offers specialized systems for select applications. Visit hamamatsu.com to learn more.
How much do we really know about MIR spectroscopy? Even in photonics, an industry and a field far more easily expressed by its applications than by its technologies, spectroscopy spanning the MIR is a bit of a mystery. The utility of the MIR region broadly is well defined, but it's a real challenge to articulate the benefits of MIR spectroscopy without measuring it against Fourier transform infrared spectroscopy, a more ubiquitous technique with a firm grasp on its supported laboratory and field applications. This dynamic underpins today's discussion with Søren Friis, who heads sales and business development at NLIR, a Denmark-based company. NLIR's MIR spectroscopy solutions enable an even streamlined industrial applications such as coatings characterization and black plastic sorting that strain many of the best-known and widely used spectroscopic and metrologic techniques. NLIR's system architecture is part of this story too. We discuss that, the company's MIR grading spectrometer, in our interview. But the undercurrent remains. How much do we know, really, about MIR spectroscopy? Friis acknowledges that part of selling prospective customers on NLIR's technology lies in his ability to articulate it. And while this most immediately means an exploration of supported applications, it also requires a look at current and anticipated trends, device portability, automation and manufacturing, and environmental accountability are just some that promise to shape the growth of a company whose technology already streamlines some rigorous and demanding applications. So there are many technologies, and I'm thinking just in terms of hardware, but I could easily be talking about software too, or both, that should they be integrated into a industrial line would seem to offer tremendous benefit to systems designers, especially in taking something beyond the lab and into real use or into the field. For you, what does NLIR see or understand as the most immediate benefits to bringing the capabilities of the mid-infrared into a functional production environment?
So we see two slightly different benefits. So first of all is production monitoring, and the other one is quality assurance. What they share in terms of using mid-infrared spectroscopy is that they're non-destructive. So you basically don't really have to touch your sample or your product in order to get quite comprehensive chemical information about it. And that it means, for example, in production monitoring, a very, very simple example is that you have a product where you develop some kind of optical property. So that can obviously be measured by a spectrometer. And that could, for example, be lenses or windows for thermal cameras, or it could be for filters and light sources for gas sensors, something like that. But that speaks kind of for itself. That more broadly, then in production, you can have different chemical processes going on, and that can be monitored by mid-infrared light. If I can mention a very, very simple example, is that the production of multi-layer plastic films that are used in passports and ID cards, they are produced by lamination. So basically you bring two plastic films together and then they cure during the production. And there you're interested in knowing whether this curing takes place in the right way. And then you can monitor using a mid-infrared spectrometer. There are other examples we can talk about if
by all means. I think we had a former editor here whose words of wisdom were profound, and he said that I think photonics broadly is best measured by its applications more than its technology. So I would invite you, to share the application examples.
Yeah, sure. So another production monitoring thing could be wooden floors or artificial wooden floors. You probably know them. These floors that are made by several different layers, and then they are sort of filled with some kind of adhesive, and then you need to monitor exactly the state of this adhesive to know whether the production is running properly. Could also be in chemical production. Then in some intermediate step, you have some liquid that you need to know, is this liquid exactly right for moving on in the production. Could be CO2 concentration in sodas. If you measure the concentration right before it goes onto the can, then you have a very good view that the CO2 concentration is the same in all your products. That is otherwise done by removing a can from the production line and destroying it. Could also be combustion processes, measuring the gases that come out of a combustion process, or measuring the light that comes from a combustion process directly.
Yeah, so the range of industrial applications is applications in general actually is really quite profound, and we will get back to the applications when we talk about the company's technology. But before we do that, I want to I think the context for this conversation is best set by talking about the mid-range and the infrared more broadly. Just describe the MIR, if you would, how it's been used traditionally before we get into what the company is doing.
Yeah, so basically what you can do with mid-IR spectroscopy is very basically you can measure what light is at different wavelengths. So the most obvious application of that is, of course, measuring light sources. How do they look? Is it a black body light source with a broad spectrum, or is it a laser light source with a very narrow spectrum? Or is it an LED, for example? And of course, everyone knows the LEDs in the visible light regime, but they're also starting to become to be developed many LEDs in the mid-infrared spectrum, mostly, I think, currently for gas sensors. But there you can use spectrometers for measuring these light sources, and in a production environment, it's to check that they are right. In R&D, it's of course to assist with the development of these light sources. Another I think broader and more used application of spectrometers is to take light from an already known light source onto a sample and measure whatever is coming back. And if you have a reference in the beginning, then from there you will know. You will get a lot of information from the sample by analyzing the light that is reflected or transmitted through the sample. And that has, like you said before, a very wide range of applications in both R&D and development to production environments also.
So when you talk about something like non-destructive analysis, right, terahertz immediately comes to mind. Just sort of without talking about application, that's the technology that comes to mind. And then as you are talking, I'm thinking about Fourier transform, right? And there's some obvious overlap between MIR spectroscopy and Fourier transforms. A lot of commonalities that are shared. And Fourier transform is a very well-established technology. Does using FTIR as a baseline offer prospective customers maybe a degree of familiarity with your capabilities? And I suppose the bigger question is, how do your capabilities differ from Fourier transform?
Yeah, sure. So in terms of to start with, in terms of terahertz, that is another upcoming technology. I think we can return to that. I'm not an expert, but we can return to talking a little bit about that. But if you traditionally, if in the mid-infrared and also long-infrared, then it is, like you say, the Fourier transform infrared method that is basically used. So that gives it's quite an old technology, and there are very good products on the market. They all use some kind of a scanning method, except for few exceptions. They use some scanning device, and then they build up a spectrum by moving a mirror or rotating a mirror or something like that. And that can give a very high resolution and a good sensitivity, but they are inclined to be sensitive to vibrations. And they also usually require cooling, because they mid-infrared detectors often suffer quite a bit from noise from themselves, basically, because they have a temperature, so they emit light into themselves. Basically, black body radiation emits quite a bit of light in the bandwidth that you want to measure. So the detector emits light into itself, and you want to get out of that by cooling the detector. So, and the way that our technology at NLIR, how we differ, is that we are building a grading spectrometer where there are no moving parts. It works quite a bit like the visible light spectrometers that are known from, for example, Avantis or Ocean Optics or many other manufacturers of those. Where you have a fiber input, and then somewhere inside you have a grading, and then you have a line array sensor, and then you read out spectra, and you can read out quite fast and with very little noise. And that's how our differs, and how we see that it's better suited for a production environment than an FTIR is, because again, no moving parts, so it's less sensitive to vibrations, and we can read out much faster, and we get the whole spectrum at the same time. So you know when you take a snapshot that it's a spectrum from this piece of sample, or from this sample that you are getting.
So those benefits are profound, right? The improvements in terms of time, and then also there are probably some benefits just in terms of integratability, right? When you're speaking to prospective customers, and obviously that's something you're doing hopefully quite often, or end users or even systems integrators, what aspects of your solution present as the most dynamic? Is it an aspect of portability? Is it the sophistication of the grading technology, the broad range of applications? The need to explain the underlying technology and make it make sense is obviously something that any new product designer has to do. So how do you do that with end users?
Yeah. So when we talk to people, it is far most often the same thing that comes up. They have, for the most part, they have some kind of knowledge about mid-infrared spectroscopy. They have, for example, an FTIR in their lab, but they want to measure something that goes on in their production, and they don't have a way of bringing that measurement to the production line. And there can be different bottlenecks there. It is often robustness, that things are just in a factory, things are shaking. There are pumps, and there are different things that makes it something, like, make things vibrate so much that FTIR spectrometers have problems. Another thing is another bottleneck could be the requirement for speed. So simply a measurement once per second or 10 times per second is simply not enough to give them the value that they want. Those are often the topics that we discuss mostly with them, and then of course we offer our technology that can help. We don't talk so much about exactly how our technology works, because it's too technical often for the person that we are talking to. They have a specific problem that they come with, and then we help them with that. Another bottleneck that we often face is the optical interface, and that is the need for interface is as different as the amount of samples that there are. Of course, some are similar, but almost a new application almost means a new interface. And that is something that people struggle a lot with if they are not optical experts themselves. So that's also something we talk to people a lot about.
So that's interesting, the optical interface bottleneck, if you will. Was that something that you anticipated as you're designing your systems and beginning to trial different applications? Because that is a real bottleneck.
Not originally. No. We were focusing on the capability that we bring to the table, the fast spectroscopy. But in time, we found out that it was actually a very good idea to put a fiber on our spectrometer, because that really helps. It's not all our customers that that use the fiber, but it's just very, very easy to work with things when you have a fiber, especially because the samples can easily be inside vacuum chambers or be in environments that are so harsh that you don't want to bring the spectrometer all the way to the sample. And then just 1 or 2 meter, it can be longer, but 1 or 2 meter fibers often solves some problems. So we have learned to think much more about how to interface samples. Yeah.
I suppose this segues nicely into a question about NLIR's own background, your background. Tell me about the origins of the company and your road to the company.
Yeah, sure. So NLIR was formally founded in 2013, but at that time it was at the university. I think there was 1 employee. I usually say that doesn't really count. In 2017, we moved to the location where we still are, in Farum, above Copenhagen, in Denmark. And we started. That was also the time I started. I came from Technical University of Denmark as a postdoc in nonlinear optics. I worked on both fiber optics and integrated optics, but mostly the nonlinear part of it. And then I started here in 17, and then I think we were around 5 for some years. But in that period, we really took what was mostly a tabletop edition, quite rough, and moved it into a product that could be assembled easily and could be shipped around the world and frankly still work when it arrived. That basically took those from 17 to 20, and in 20 we really started shipping products. From since then we have grown steadily every year. In 2023, we had the chance to be part of a German photonics group called the NLIR group, and now we are part of that, and that gives a bunch of benefits. But we are still ourselves, and we are still developing our products, and we are increasing our visibility and our sales around the globe.
Couple questions about I guess future-looking questions for the company, and there are a number of applications that you've mentioned so far. Some may be more automatic, maybe that's not the right word, easy fits for the technology than others. From where you sit, the platform of your position, what are some of the applications that present as the best fits for NLIR's technology?
Sure. The easiest thing to do is, of course, as I mentioned in the beginning, working on measuring things that have optical properties. So we have a customer that's from a while back that makes infrared coatings on different substrates. And we have a couple of those, but one we are in very good contact with, and they are really seeing some benefits from using our spectrometer to do live monitoring of their production. Basically, a production of these optical coatings happen on a disk that spins around where there's some deposition somewhere, and then on the other side you can do transmission spectroscopy on that sample, I think, as far as I understood, they have between 5 and 10 milliseconds to measure every sample, and there's simply no FTIR instrument that can do that. But ours can do that. So they are using it to do a production optimization, to both get better quality, but also to simply reduce production time. That's very much the easiest thing. If we see a bit broader, then there's a number of other things. I think that the one that is easiest to relate to is plastic sorting. That happens a lot in the visible and near infrared. But as soon as there are black plastics involved, then near infrared doesn't work anymore. And that's really I've come to understand that it's actually a very widely needed capability to sort plastics. Most people think about consumer plastics, but that's not really what we are talking about. It's very difficult to make a business case with consumer plastics. It's more companies that want to go full cycle. So they want to take in their own old products or even other companies' products and sort them before using them in their own production. That really helps them with the full cycle. That helps their ESG reporting and also their own advertisement, that they become more sustainable that way.
So that's an interesting application there, and it raises the question of environmental consciousness or consciences, rather, conscience, environmental wellness. And there are a number of other trends too: device portability, automation in manufacturing, hardware automation, that could evolve in such a way that your technology is apt to be influenced, right? That could affect your technology. Are there any trends, I would call them macro trends, that you see as poised to influence the future direction of NLIR?
Yeah, I would definitely say automation. That you have some kind of sorting, production, quality assurance going on, and you would like to do something automatic there. That you wouldn't want some. It can be in different points. If it's in the beginning of your production, it could be for some kind of PID control back to whatever is preparing what's going in. It could be later on to check, are things actually right here. Raise a flag if something is not right, or even give instruction back. You want to centralize the surveillance of your production, and the bigger the production is, the more relevant this issue is, and that is the big trend that I see. There are, of course, also other things of portability, taking the spectrometer out into the field somehow. That is, especially in heritage science, something we see that's very important. It has become a complete no-go, of course, to remove heritage objects from where they are found. That was done earlier, and not anymore. So now you really need to be able to bring all your equipment to those sites to do the measurements that you want. It could also be in agriculture. It's also important to be able to bring equipment to where the production is. And of course, there are also, just briefly mentioning, some defense application, of course, like surveillance of warm objects, so to speak.
I've generally referred to NLIR's technology or its solutions, but in fact, this is a commercial entity, and there are products. Tell us about the product offerings made available by the company.
Yeah, sure. We have our spectrometer that I'm happy to talk about how it works if we should do that. But we also have other things. We make a few different light sources. They are by no means state of the art. It's black body light sources. They emit light, but they make it easy to interface with different samples. That's the idea: provide plenty of light to your sample in whatever way is needed. We are also happy to customize them so that it fits to the customer's needs. Then we have what is called an upconversion module, and that relates strongly to how our technology works, where what it does is basically take mid-infrared light and convert it to near-infrared light or visible light, just around those wavelengths. That we also use in our spectrometers, but that device is mostly for fairly expert users. But we imagine in the future it can also be used in production facilities if people invest enough in installing them. We also have a bunch of interfaces just to easy access different kinds of samples that we have made in the past. But again, they are also very customizable. I should say that is like one of our services, is to customize things for people. Again, as I said before, there are so many different things, and we don't want a fairly simple interface to be the roadblock between the customer and a good solution. So that we are spending quite some resources on.
Feel free to answer this either as an NLIR person or a scientist person. A grading spectrometer, how does it work? What are the component pieces that enable this technology, and how does it function as it moves into an application?
Sure, yeah. In a standard grading spectrometer, then you have some kind of a slit, like a small space where the light passes through, and often you would bring the light to that slit through a fiber. And then in the most basic version, then after the slit, you have a lens or mirror that collimates the light. You have a grating that spreads the wavelength, and then another lens or mirror that focuses on a chip. And then basically each pixel on the chip corresponds to the information from one wavelength. And then you can tune and have different wavelengths and different ranges, different resolutions, but that's how it works. How ours work relative to that, because I said ours is a grading spectrometer, and it basically is, but before the infrared light enters any kind of spectrometer, then we pass it through our upconversion unit, we call it, where we convert the light from mid-infrared light to near visible light. Around 2 to 5 micrometers is converted to 700 to 900 nanometers. And then that conversion happens inside a crystal where there's a nonlinear effect going on. We have a high power laser in there that the user knows nothing about. It's all inside. The user only puts in mid-infrared light, but then this process happens using the high power laser. It's at 1064 nanometers. And then we convert to the 700 to 900 nanometers. And after that, we have our own spectrometer that works exactly like the one I mentioned before, where the slit, so to speak, is this laser where we upconvert. But the sum of those just gives the user an experience of putting in mid-infrared light, and out comes a USB or Ethernet cable with the information that you are asking for. So it can, depending on your background, it can be a bit difficult to understand how it works, but the user doesn't see that.
We've been talking all things mid-infrared spectroscopy here on the All Things Photonics podcast today. And Søren, I want to end with this. Here we speak now at the, I suppose, still beginning of July. We're all back from Munich and Laser World of Photonics. How was the show for you, and how was the show for the company?
So yeah, I enjoyed the show, of course. I always like going to the big photonics shows because the most important thing for me is to talk to the people there, to new, of course, meeting people I've seen or only met on email or in meetings, on online meetings. Seeing them in real life makes a complete change for the future collaboration. So that's very important. But of course, also distributors, our old partners. So that's what I enjoy most about the show. And there was plenty of a chance to do that. For NLIR, of course, we go there to meet new customers. So that's obviously that I think everyone does, but it's the purpose is much broader than that. Really, we are talking again to, of course, our distributors. We're talking to our Nynomic partners that we don't get a chance to talk to that often. So that's really beneficial. And then, of course, we have also existing customers coming by. That's really valuable to talk to them, both to get feedback and also to talk about new projects. That means a lot to have this person-to-person conversation. And then we also had our people from our R&D department there. They were presenting their work at the conference next door, and they could also sort of send people to our booth and have good conversations with them. And then especially the Laser World of Photonics show it has many purposes for us, and it works really well for us, and I'm super happy to go there.
Well, excellent. I appreciate your time again. It's been a pleasure hearing about NLIR and the technology that supports it. Thanks for your time, and we'll talk again soon.
Thank you.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.